This tutorial is going to teach you how to do redox reactions and half reactions of various elements. So to start off with the key idea is breaking down what you know. So we have magnesium here and it says the term atom. Whenever you see that term atom, assume a neutral charge. Second thing is that we have the term ions. In this case, we know that an ion is an atom that has a plus or a minus charge. So how are we going to figure out what the plus or minus charge is? So to start off with magnesium, we know that it has a neutral charge. And we're going to look at the periodic table to determine how many electrons it has in its outer shell. And we see that it's in the second column, and so we're going to give it 2 electrons. So this is combined with zinc. Zinc, I know, is an ion, but what charge does it have? If it doesn't give me a Roman numeral here, I look at my polyatomic chart and I recognize that the polyatomic chart says that it has a +2 charge. So in this case, we have magnesium that has electrons in its outer shell, zinc that does not. It has a charge. So what's going to happen is that magnesium is going to give its electrons to the zinc. So we have magnesium that no longer has its electrons, and zinc that now has gotten those electrons. Sorry that these circles are a struggle to get drawn in here. So let's do a quick inventory of what we have. So magnesium, just to remind us, we have 12 protons. Because it has that neutral charge, I know I have 12 electrons. So that gives me a 0 charge. Now magnesium no longer has those 2 electrons. Remember, it's passed those on to the zinc. So now it still has those 12 protons, but because it lost those 2 electrons, it now has 10 electrons. It has a +2 charge. Hence why you put +2 here. Zinc, on the other hand, zinc has 30 protons. I know this by looking at the periodic table. And I know that its electrons do not equal the protons because of this charge. So in order to get that +2 charge, I need to have 28 electrons. And that gives me that +2 charge. Where in this case here, zinc has gained those 2 electrons, so it has 30 protons, and it has now 2 more than 28 electrons, so it has 30 electrons. And that gives me that neutral charge. So our next step is doing those half reactions. All right, so I like to do the reduction one first. I feel like it's a little bit easier. So reduction, remember our term oil rig, is where the element is gaining electrons. So let's take a look here. Magnesium had 12, and then it has 10. So clearly this one did not gain electrons, it lost electrons. Zinc had 28, and then ended up being with 30. So this zinc did in fact gain electrons. So we write zinc with its +2 charge. I more or less copy it on this side. And on this side, remember, this does mean add. Okay? It added or gained 2 electrons to become zinc that is neutral. For our oxidation reaction, remember, oxidation means it's losing electrons. This one here is where you have magnesium. It had 2 electrons, and then I sort of see that arrow as now you have magnesium that has been separated from its 2 electrons because it's lost them, that you see these as separate. Okay, they are no longer a whole, they are 2 parts. Okay, the next thing is finding the reducing agent, I should say. Reducing agent. So the reducing agent is the one that caused the element to reduce. So zinc added electrons, and the reason it did is because magnesium gave it that. So it's always the opposite. So in this case, if zinc is in our reduction reaction, our reducing agent is the magnesium. For the oxidizing agent, we have then the zinc. Magnesium lost its electrons, and the reason is because zinc gained them. So that's solving that sort of problem. Now let's take a look at one that's maybe just slightly more difficult. We have silver ions reacting with lead 2 atoms. So again, ions tells me it has a plus or negative charge. I look at silver and I don't notice a Roman numeral. So for that reason, I'm going to look at my polyatomic chart, and I'm going to see that silver always has a plus charge. All right, the next one, atoms. Atoms gives me the clue that it is has a 0 charge. In this case, I do have a Roman numeral, and this tells me that it can either gain or lose 2 electrons, depending on the scenario. So right now we know that lead, which is Pb, has a 0 charge. So it looks like it can lose 2 electrons, so we know it has 2 electrons on it right now. So here's the thing. Silver, because of that +1 charge, I know can only take in 1 electron. So one of those electrons this electron can go to this silver, so now I have Pb plus that electron that went to silver, but there's still that other electron left. So I need to make sure I have another silver so it can take on the other electron. Because lead gives 2 electrons away and silver can only take 1 at a time, that means I need to have 2 silvers so that each of those electrons goes someplace. So now we have to work out those charges. So to start off with, we know that silver has 47 protons. And in this case, it has a +1 charge, so that tells me it has 46 electrons. The lead, on the other hand, when I look at my periodic table, tells me that I have 82 protons and 82 electrons. Those are those positive and negative charges. Those work out to be 0. So now I just mentioned that lead gave those electrons away. It still has those 82 protons, but in this case it gave 2 away, so now it has 80 electrons. So if I do my positive negative charges, I see that lead can be +2, which makes sense because I said that it was +2. Silver, on the other hand, each of these gained 1 electron. So it had 46 and now it has 47 electrons. That means that they are now neutral. All right, so let's work on the half reactions. Again, like I said, I think reduction ones are a little bit easier to do because it makes a little bit more sense in terms of the equation. So reducing, remember, in terms of oil rig is gaining electrons. So here I have 26 electrons, and on the other side there's 27 electrons. So clearly this one has gained 1. So we're going to have Ag be the one that is doing the reducing. So we have Ag plus, and then we can say an electron. So now here's where I'm going to stop. You notice on this side I have 2 Ags. That means on this side I have to have 2. So we can write it like this if we want to. Okay, so that's those 2 Ags. Those of you who want to write it like this, that is perfectly fine as well. Makes no difference. So I'm going to write, in this case, the 2 Ags, just to make my life easier. And each of those Ags gains 1 electron to be 2 Ag. All right, so that is the reducing because it's gaining. For oxidizing reactions, we have lead. Lead, on the other hand, has 82 electrons, but then ends up with only 80, so it has lost its electrons. Again, I should use my arrow as maybe that hand that is separating them, tearing them apart, that I now have lead with a +2 charge, and separate from that lead are 2 electrons that left. All right? So now we just need to do our reducing agent. The reducing agent is always opposite to the one that has been the reaction. So in my case, because silver is in the reaction, the thing that reduced it was the lead. That means that the lead gave those electrons away so that silver could take them. The oxidizing agent is going to be silver. This is the one that, in terms of oxidizing H's, this one gave those electrons away, and the reason is because silver received them. And that ends your tutorial on redox reactions.